Hello everyone, this is Ashwin here. In this video, we're going to see how to summarize large and multiple documents with the help of LLM using LangChain framework. So in the previous video, we have seen how to summarize a single document or a reasonable context size document into a short summary. If you consider a real-time use case which might be very difficult, because if you have like multiple research paper and you need a concise summary of that research paper, you have to do this approach, because usually for any kind of LLMs currently the context size is much larger compared to the previous year. But even for smaller models, if you want to do some summarization, means you have to do this approach, which can use map reduce approach. What it does is, first it will summarize some portions with a fixed token size, and it will try to combine all the summaries and do the summarization for those summaries. I know this is like tricky, but I will explain you with the graph approach how it works. So it's like a divide and conquer approach. So we will take some context of the document, summarize it, and we will repeat the steps until we reach the final summary. So that's the overall idea, but we will see how to do it in the code. So this is somewhat like a lengthier video, because we have to like build some state graphs and connect everything to do this. But once everything is done, it will be a very optimized approach which can be applicable for like a shorter summary, or even if you want to summarize a whole book, you can do this with this approach. Okay, so again we will install the recommended modules. So pip install qu, we need LangChain, LangChain core, LangChain community, LangChain Olama. I'm going to use Olama model for this tutorial. Again, if you want to use OpenAI, you can also use OpenAI. So I will also add that in the pip install. By now, I think all the modules would have been installed if you have followed the previous tutorials. And we need LangGraph as well. Okay, so these are the modules that you really need for this tutorial. Let's import the modules. So first let me import LangChain modules from LangChain. Okay, I'm making some mistakes. LangChain core. So we have to create some prompts. So for that, chat prompt template, chat prompt template. Okay, again from LangChain core, documents, import document. Then from LangChain Olama, import Olama LLM. Then from LangChain text splitters, import character text splitter. You can also use recursive character text splitter, which we have done in the previous few videos. Then and LangChain community dot document loaders. Okay, just created additional same sentence. So from the document loaders, I will use PyPDF loader, and from LangChain dot chains dot combine documents dot reduce, import a collapse docs and split list of docs. Then from LangGraph dot constants, import send, and from LangGraph dot graph, we will import like the graph modules, that is start end, and state graph. Okay, so these are LangChain related modules, and a few more basic modules which we need. Import operator, from typing import annotated list, literal, and type dict. So this is to define the formats of the states which we are going to create. So this should be needed. This is like similar to the Pydantic module where we create a class for structured output, right? So similar way we are going to do the same, but here we are going to use all these modules. Let's run this. Okay, all the modules have been imported. Then we will initialize the LLM. So here I will use Olama LLM model equals llama 3.2. Make sure to install Olama and pull the llama 2 3.2 model. And if you want to use OpenAI, from LangChain underscore OpenAI, import chat OpenAI, and here also I will just use the model. So GPT 4o mini. Okay, I'll just comment this, and for this I have to just open the Olama, otherwise it will show some error. Let's run this. Okay, this is done. Let's just do some basic test just to see everything is working fine. Okay, so this is working fine. Now this is done. Let's create some prompts. Create map reduce prompt. So again, you can customize the prompt based on the summarization that you want to do. If you want to extract key information and just have it in the summary, you can also do that. Or if you want to get a high level understanding of the content, you can also phrase the prompt accordingly to get the final result. So based on the prompt only, you will be getting the final result. If you give some prompt and expect some other thing, it won't work that way. Okay, so map prompt equals chat prompt template, from messages a list. Inside the list I will have the system prompt. I'll just say write a concise summary of the following, a new line, and context. So this is it. So this is the prompt I'm going to pass for the system prompt for the map prompt. Then we have to do the same for reduce prompt. So reduce prompt template. So this is a multi-line prompt, so that's why I'm just keeping it in a separate variable. The following is a set of summaries. So as I said, each map prompt will return a summary, and all these summaries will be reduced in this reduced prompt. So here docs, and take this and distill it into a final consolidated summary. So that's all I'm going to give, and let's just leave some space like before. You can also write this in the multi-line approach. So this is much better. Now we will create the reduce prompt. So reduce prompt equals chat prompt template dot from messages, same thing, but here I'm going to use user message and reduce prompt template. Okay, so these are the prompts we're going to use. Let's run this. Okay, it ran successfully. Then we have to load the documents and split it into multiple chunks to pass it to the map prompt. So load the documents. So for now I'm going to take a long research paper which I have been using for this video. So file path equals data slash llama research paper. So this is the file I'm going to use, and loader equals py pdf loader. Again, if you want to iterate through the folder and consume all the PDF that is present in the folder, you can also do that. You just have to change the code snippet a little bit, and loader.load will be giving the docs, and you can see there are around 27 pages. If let's say if you are using some iterative approach and loading all the documents, you can just extend this document list. It is a list of documents, so you can just extend it and follow to the remaining steps. Okay, now we have to build the state graph and the corresponding functions for that. So for now we have around 27 docs, but if you just load everything in a single document, then we could use that text splitters character splitter or sentence splitter. But for now we can just directly use this 27 docs as it is. Now let's create that states. So define the maximum token. Define the maximum token for the summarization. So token max equals, I'm going to set it as 2000 tokens for now. If you want based on the limit that you have, you can set it the token size more or less. Okay, then class overall state, it will be a type dict. So I will also have the comments inside it. Consists of all the states of the graph for summarization. Okay, so here I will have the contents, which is the original contents. It will be a list of string, then summaries of that content. So annotated of list comma operator dot add, because we are going to concatenate all the summaries to do the reduce part. Then collapsed summaries. It will be a list, it will be a list of document. So this will have a result of this from all the summaries. We will just collapse it to have a reduced content, and from here I will have the final summary. It will be a string. So this is the overall state. Then class summary state, again it will be a type dict, and here I will have the content as string. Then function to generate summary. So this is a first map prompt. So async, everything will be in the asynchronous manner. So generate summary of state, summary state will be the input, which is this, and from that I will have the prompt. prompt equals map prompt, which is the prompt we created earlier, dot invoke of state of content, which is this contents, then response equals await of LLM dot a invoke of prompt, then we will just return the response as summaries. So this is like a step-by-step process. So it will just asynchronously run these steps and return these results. So return, I will have the summaries as the response. It will be a list. So everything will be like concatenated with each other. So this is generate summary, and we will map the summaries. So we have to like pass the content to this generate summary function. So function to map the summaries to the function def map summaries of state will be overall state. I'll just say return in a list send of, pass the function name which is generate summary, and the arguments which will be content. So this is this content. I'm just passing it the content here, and we will loop the content for content in state of contents. This is similar to oops because we are just accessing the class and variables in the same way. So this overall state will have this content, right? So I'm just iterating those contents and passing it to the function. Okay, now this is done. Next we have to once we collect all these summaries, then we have to like collect the summaries and collapse it. So function to collect summaries and collapse it. Okay, def collect summaries of state of overall state, then return. I have to return this collapsed summaries. So collapsed summaries of a list. So it will have the list of documents. So that's why we are having the same here. So list document of, and inside this list for summary in state of summaries, pass the summary here. Okay, so this will have all the collapsed we are just collecting the summaries here. Then after that we will just collapse it, which is function to reduce the summary. So async def reduce summary of input will be dict prompt equals reduce prompt dot invoke of input. Maybe I will say input dict and response equals await of LLM dot a invoke. Similar to the map part, we are just doing the same, and then we will return the response. Okay, now this is done. We have to create another function for collapsing. Function to collapse summaries. So async def. Oh, this is def collapse summaries of state of overall state so doc list equals split list of docs state of collapsed summaries okay, I think we missed one function, which is the length function. We will just create it now, and then token max. Okay, let me quickly create that length function here itself. Def length function of documents of list of, so this will be square brackets, list of document return sum of LLM dot get num tokens of doc dot page content. We're just checking the size of the page content that is present in the document. So for doc in documents, so this will just split the summaries based on the token max that we have, which is 2000, and this should be closed. Let me just check. Okay, I think it's already closed. Okay, for doc and documents, okay, this will return the length of the document, and we will pass the length function here. Okay, now that is done. Now results for doc list in doc list results dot append of await collapse. Okay, we do have another function, a collapse docs of doc list comma reduce summary. So this is the reduce summary function which we have defined. So this will just reduce all the summaries we have. Then we will return collapsed summaries results. Okay. Then lastly, we will define some condition whether it should collapse the summary or it should call the final summary. So def should collapse of state will be overall state. Now num tokens equals length function of state of collapsed summaries. Oh, state of collapsed summaries, and if num tokens is greater than token max, then we will return collapse summaries. Otherwise we will return generate final summary. So final summary is the function which we are going to create here. Collapse summaries is the function here. So it will just collapse it until we reach that token max which we defined above. Okay, now def. This is async of def generate final summary of state, overall state, response equals await reduce summary of state of collapsed summaries, and then we will return the final summary which we defined at the top as like a string. So dictionary final summary will be response. So as I said, we will have all the inputs in the contents, then we get initial summary using the map prompt, then we will combine or collect all the summaries and put it in the collapse summaries. Until we reach the token max state, we will just do the collapsing summary using the reduce summary function. Then once we reach the sufficient token max, we will finally generate the final summary string. So that's how the workflow goes. Now let's run this. Okay, I have missed. What did I miss? Okay, if I remove this, I think it should be fine. Okay, now construct the graph for summarization. Okay, so graph equals state graph of overall state. So the graph will have all the states. Then we will create separate nodes for each function. So graph add node. So it will be a string and the function name. We have to do this for like 4 times. Oh, 4 times. Mistakenly, I just ran it. Okay, so we need generate summary, which is the first one, then collect summaries, okay, then collapse summaries, collapse summaries. Finally we have generate final summary. All these are functions. I'm just defining a node for those functions to call it like step by step using the graph. So generate final summary. So all these are nodes. So nodes, then we have to define edges. So graph dot add conditional edges of start map summaries and generate summary. So conditional edges means it will just exactly follow the straight edge without doing like any if condition that we created in this should collapse. So that will be like a conditional edge. So graph dot add edge of from the generate summary. From the generate summary, we will pass it to collect summaries. Like once the function is done, we will collect all the summaries. Then graph dot again add conditional edges of collect summaries, we will call should collapse. So based on this condition, it will call either call should collapse summaries again, or it will call generate final summary. So we have to do the same for collapse summaries. So graph dot add conditional edges of collapse summaries, again should collapse. So whenever we get the final summary, we will just add it to that, add an edge. Once we get generate final summary, we will end the process. Again, if you have like more process, like if you want to extract major entities from at the end of the summary, you can also add some additional edges and nodes to do the process accordingly. So this is it. Now app equals graph dot compile. So this is a summarizer, so I will just call it as summarizer itself, and compile is a function. Now this is done. Let's display the graph. It's better to like double check using visualization, so that's why image and image of summarizer dot get graph of draw mermaid png. Run this. Okay, so this should not be the case. It should not have like multiple undirected edges. Like it's just showing this can be possible, but this should not come. I think it's due to the written state. I didn't mention it here. So this will have literal of, it should have either collapse summaries or generate final summary. Okay, and reduce summary will return a string. Let's see whether this is enough. I think it's some timed out error has happened. Maybe we will come back to this again. So usually it will display the graph with have like only the edges which we formed here. The only way it will have like a loop for these edges, like should collapse. So because in should collapse, it can either redirect to collapse summaries again, or it can go to the final summary. So we will wait for this to get up. So this is like a request module in the backend. It's just getting timeout. So let's just leave it for a while and do the rest of the coding. So result equals await dot await summarizer dot a invoke. If you want to get the final summary alone, you can just use it. So inside it you need contents. Contents will be a list. So for doc and split, I think we can use docs. For doc and docs, doc dot page content. So this will have like all the page contents. And one more thing here is recursion limit. This is comma, and recursion limit equals 10. Sometimes that collapse summaries as it has like a cycle, we have to like set this limit, otherwise it will show some error. And the result will be stored in the result variable, and from that result we can get the final summary. Let me just try to run this again. I think it's still not running. Let me wait for a while so that the graph is up and running. Okay, after rerunning it for a couple of times, the graph is generated. So this is the start. From the start, we will just pass it to all the contents to the generate summary to generate the initial summary. And from that, we will be collecting all the summaries. Then it will be passed to the collapse summary. The collapse summaries can be called again and again until we reach the final summary. Then it will be called to the final summary, and it will reach an end. So this is the whole graph, and let's run this now. So this will take some time because we have like multiple contents inside this, and based on the token limit, it has to do like multiple summarizations, and it also depends on the local model which you are running. If the model is very big and it's just occupies the entire GPU, means it might take some time, depends on your power of the GPU. So if you're using OpenAI, I think it'll be slightly quicker than this. Okay, something has happened. Name summaries is not defined. Okay, I think, okay, this is a string. Let's just rerun this. Yes, this is a long code. I think these errors are prone to happen. Let's wait and see if this works. So once we got the results, we will have like result.keys to see what is inside. It will have the overall state which is present in the graph. Let's just wait for a while. So this will have like all the keys that is present in the result. Then we can just okay, again it has some error. Results is not defined. Okay, let's just run this again. I think I have made some silly mistakes inside the functions. Okay, now the process is completed. Let's just run the keys. So we have like all these contents. So print result of final summary. Now this is the final summary we have got within the limit of like 2000 tokens. As you can see, just have the consolidated of like 3 documents. I think in the collapse summaries we have like 3 documents. Let's also find the length of that. Length of result of collapsed summaries. See, we have like 3 collapsed summaries. You can also check inside it how the content are structured, and this is the whole summary you can get. And in the similar way, you can also do this in an asynchronous streaming manner. Let's say if you want to like see the progress, you can also do that. So for that, we just have to like copy the same. So here async for step in summarizer, all the rest of the process will remains the same, and then print step print list of step dot keys to see which function is calling. Okay, let's run this. This is async So this is a stream. Okay, now you can see it's just generating summary from the list of documents we have. So first it's just like mapping the contents and generating this summary. So this will have like 27 summaries, and then it's doing collection of all the summaries. Then it's collapsing it, and final summary is generated. Okay, now step of generate final summary of final summary. I'll just print this. So this is the again the final summary. So each time the summary will be slightly different because it depends on the model temperature and the nature of how it gets summarized. So compared to the previous one, this is like very shorter summary, I would say, because the collapse summaries have like a single summary. And that's pretty much it, guys. So this is how you can do summarization for large or multiple documents with the help of LLM. And it's very useful if you want to just go through the main content of the context which you are reading or researching. And I think if you have any other queries regarding this video, please leave a comment below. I'll be happy to assist you. Other than that, if you like this video, hit the like button and don't forget to subscribe the channel for more videos like this. Stay tuned for the next video.